Good morning all, this is Yogesh URK17CS077, and in this session of video we will see the merge sort algorithm. Okay, so the merge sort is very fastest algorithm as well takes only n log n in worst case scenario, and we will see how it is implemented in C++. So this is our code for merge sort. So merge sort does what is it takes an element, the middle element, and that middle element will have all with that middle element of the array will divide the array into subparts, and we will sort the subparts individually, and then we will sort both the subparts, and we will compose it or compress it in our original array, and we will sort the whole array. So this is again the game of recursion. So as you can see that first the program will start from the main operation, and we will ask to enter the elements. The number of elements here I have given is 7, but you can ask the user to enter any amount of elements. It depends upon you. And once the element has been inserted, then a merge sort function will be called, in which the 0 will be the very first index, and p minus 1, that means the last 7 is our p, that is the size of the total number of elements, minus 1, that is the last element index, will be given as the parameter to the merge sort function. So the merge sort function will be here at the very top, sorry, at the here, and from this we will create the middle element as I said, and we will create two sub arrays, one from 0 to the middle, and other from the middle to the high, and again we will have a recursion call of merge. Now this time the recursion call will be to merge, and the parameters will be low, high, and middle. So the merge function will have three parameters, and now we will see uh, if the element to the one array is smaller to the element to the next is smaller than the element of the next array, and if it is smaller, then we will swap it in k, that is the original array's index where we are sorting it. Okay, so that will be the case for these two. If it is smaller than j, then I will be given, and if it is larger than I, then j will be given in order to sort it. And if for we have given these two separate because if for example one of the sub array gets exhausted, then our operation should not be stopped. So that's why we have given this individually in order to get it going. So this was merge sort, that is pretty easy algorithm. Now let's run this and see if it is working. 3 1 8 9, give any amount of elements you want. Here I've given 7, 6, and let's give 2. Okay, so this was merge sorting. As you can see, we have a output, we have different type of partition, different type of recursion calls, and at the end we have a sorted number of arrays as an output. Thank you. Good morning all, this is Yogesh URK17CS077, and in this session we will see how the quicksort is implemented in C++ algorithm, in C++ programming language, the quicksort algorithm. Okay, uh, so this is our code for quicksort, and as we know that the quicksort, the average case complexity of quicksort is O of n log n, and the worst case is O of n square. But instead of being a worst case of O n square, it is a in place sorting algorithm. That means that it can have a very good real life implementation instead of being a time complexity of O n square. So what we do in quicksort is we just take an array, and we take a pivot point of the array, and that pivot point will have all the elements to the right of it greater than it, and all the elements to the left of it smaller than it. And the recursion is the main cream of the sorting, because we just take an array, make a pivot point of it, and then we make a recursion call like this one, quick 0 and minus 1. That means all the elements to the left of the pivot will be sorted first, and then that element will make again a recursion call like this one. That means it will take the first element till the pivot minus one element. J is the pivot, so pivot minus one element, and that will be the first part of the array. And the second part of the array, that is the right of the pivot, will have j plus 1 till the very end of the element, that is u. So it will have recursion after recursion, and it will make the calls. And what is happening in quick is it is making a call to partition function. Now partition function, what is happening is we are just making a base condition. If the start is less than end, and if the start is less than end, then the recursion will not be performed. That means the operation of swapping will not be performed. And if it is not less than end, then it will be performed, and then it will make a call to its prior recursion. And in the same way, all the elements to the left of the pivot will be sorted, and then all the elements to the right of the pivot will be sorted in the same way with the base condition, so that the recursion does not go to infinite. So now let's run this program and see. The five elements to be here is 9, 3, 2, 6, and 1, let's say. So yes, as you can see that we have different partitions. So in the first part of the partition, what happened is the all the elements to the right of the pivot was being sorted out. Like the 9 was at the very right, so it was being sorted out to at the end place. Now the 3 was taken, and 3 was placed. Like this, all the elements were sorted, and at the very end we get our sorted elements, that is 1 2 3 6 9 in ascending order. So this is how quicksort algorithm works. It has a time complexity of O(n) square in worst case, but it is a very good real life implementation algorithm. Thank you.